Okay, so now that we've looked at the types of questions you'll be asked, the information that you'll be given, and how to find given information from a table like this, now let's go into what it is you actually need to do. So in almost all cases, the first thing you need to do to answer the problem is start by finding the half-life cycles. So remember, that's the number of times the isotope has decayed by half, or the number of half-lives that have occurred in the problem. Now, to find the half-life cycle, there are two ways that you can do it. So let's start off by looking at those two ways, and then we'll go into detail into both of them. So you can either use a table, either if you're given a table, or you can create your own table, or you can use one of the equations that you have in your notes, okay? So these are the two types of main ways you can find your half-life cycle. And remember, for all of these problems, your first step is finding that half-life cycle. So let's start off by looking a little bit more closely at in a case where you're either using or creating a table. And for that, we'll do the one where we're creating a table, since if you're given the table, it's the same process. In fact, it's actually less work, because you actually got to figure out how to create the table. So going back to the example problem part 1, where you're given this information, 7.5 milligram sample of chromium-55 is analyzed after 14 minutes and found to contain 0.469 milligrams of chromium-55. What is the half-life of chromium-55? Well, my first step is to find the half-life cycle. And let's consider the information that we're given here. We're given the initial amount. We're given the elapsed time. And we're given the final amount. Okay, so initial, final, and elapsed time. And we want to find our half-life cycle. So I'm going to try the table strategy because this is actually a pretty easy strategy, and it's also very useful for many things. So for the table strategy, what you're going to do to find the number of half-life cycles is start by creating a table with time on the X and amount on the Y. You're always going to start your time at 0. So in fact, you don't even really need to worry about the time section. It's more about the amount. And in fact, we're going to actually change this to HLC. So I should say this should be HLC, half-life cycles, and amount. And you're always going to start your HLC at 0. And then your amount is your initial amount, so 7.500. So I have my initial amount here. Then what I'm going to do is I'm going to keep having my initial amount until I get to my final amount, okay? So basically you create a table and you keep having that initial amount until you get to the final. So the final amount that I'm aiming for in this problem is 0.469 milligrams. Okay, so I go ahead and I divide 7.5 by a half, and that gives me, so divided by 2 I should say, 3.75, and I divide that by a half and I get 1.875, and I'm not there yet because I'm not at the final amount, so I divide that by a half and I get 0.9375, and I divide that by a half and I get 0.46875, which, if I use my sig figs to cut that number off, is my final amount. So now I can stop because I was able to have my initial amount, 7.5, 1, 2, 3, 4 times to get to the final amount. Okay, I'm at the final amount, I can stop. And so how many times did I have it? 1, 2, 3, 4. So that means my number of half-life cycles is equal to 4. Okay,